All right, guys, we're back together again. And today we're going to talk about, we're going to do a little review. So, because I kind of feel I rushed through the end of the last video with this. So I do want to review simplifying products and quotients of radicals with different indexes. And then we're going to talk about the Pythagorean formula and the distance formula. So these last two you did in geometry, so we're going to do a little review of those. So again, let's talk about simplifying products and quotients of radicals with different indices. All right, so the square root of 5 times the cubed root of 4. Now, when we have different indices, we have to come up with a common denominator, and we have to write the radical using that new index. So 5 to the 1/2 power, we have to be, because 2 and 3, right? So this is actually 2 there. So we have to find a common factor between 2 and 3, and that's 6. So we're going to convert 5, the square root of 5, into the 6th root, if you'll see here, of 5 cubed. And then you go ahead and you just cube 5 and get 125. Then you do the same thing with 4. So this is the cube root of 4, which is 4 to the 1/3 power. Well, thirds become 2/6. So this goes to here. And then now we convert this to this. So this is the 6th root of 4 squared, which is the 6th root of 16. Now you're going to take these and recombine them. Okay? You're going to recombine them into the problem multiplication. So you're going to substitute. All right? So you're going to substitute for 5. The square root of 5 is equal to the 6th root of 125. The cube root of 4 is equal to the 6th root of 16. You're going to multiply those two and end up with the 6th root of 2000. So this is the method of doing that. So let's do one more example for you. So the square root of 7 times the cube root of 2. Okay? So again, we got to keep in mind that this is 2. So the square root of 7 is equal to 7 to the 1/2 power, right? So 7 to the 1/2 power in sixths again, right? Because we want to find the least common multiple between 2 and 3, which is 6. So 1/2, that's equal to the 7 to the 3/6 power. So, excuse me, that's going to be written as the 6th root of 7 cubed. And 7 cubed is equal to 343. So this would be the 6th root of 343. Now we're going to do the same thing with 2. So the cube root of 2 is equal to 2 to the 3/2 power. Excuse me, 2/3 power. No, excuse me, 1/3 power. Oh my gosh. I only had a half a cup of coffee. I need another one. Anyway, so we're going to convert that into sixths. So this becomes 2 to the 2/6 power. So this is equal to 6th root goes here, and 2 squared stays here. So this is equal to the 6th root of 16. Nope, my bad, 4. What am I doing? 16. Oh, God, help me. 6th root of 4. Okay. Now, we're going to go back and put these back together. So these two here are going to be put back together. So we're going to end up with the 6th root of 343 times the 6th root of 4. Now we can multiply these. And 343 times 4 is 1,372. Okay, so hopefully that's done a little better than I did the last time. I kind of rushed through things. I don't think I did another example like this. And I certainly, well, 2 squared, 4, 16, wow. Anyway, all right, let's talk about the Pythagorean formula. So, we've known this for a while, right? A squared plus b squared equals c squared, right? If you square one leg plus the square of the other leg, it's equal to the square root, or excuse me, the square of the hypotenuse. So, that's just a thing to remind me that our meeting is at 9:35. Anyway, so we need to find the unknown length of the side in each triangle. So basically, all we're going to do is take 8. So the formula, c squared equals a squared plus b squared. So c squared equals 14 squared plus 8 squared. So 196 plus 64. So c squared equals 260. Well, we want to know what c is, so we're going to take the square root of each side. So c is equal to 260, which is the square root of 4 times 65. So 4 being a perfect square. So that's 2. C is equal to 2 times the square root of 65. I did post some notes from Mrs. Smola on how to further simplify square roots and radicals. And so please watch that when you get a chance, because it's really good. And I didn't want to duplicate the wheel, reinvent the wheel, so I just borrowed it from her. Anyway. Okay, let's try this again. So we're going to talk a little bit about the distance formula here. Now, the distance formula was derived by applying the Pythagorean theorem to the coordinate plane. So we have here c squared equals a squared plus b squared. So if we take the square root of each side, c is equal to the square root of a squared plus b squared. So the distance formula was figured out that if I have a triangle, it's a right triangle, and I start at here's my right triangle, and I start at the origin here, and the coordinate of this is at 0, y, and the coordinate here is at x, 0. Well, we know that to figure out a, let me put that in a different color, so here's a and here's b. What they figured out is if I take x minus 0, that'll be the length, that'll be equal to a, right? So a would equal x minus 0, and b would equal y minus 0. So they plugged this into this. They figured that this must be true anywhere. So they figured out that c is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And that's how they figured this out. But we don't care about that. We just want to do this. Memorize this formula. Yes, I realize how hard it is for people to memorize this, but it can be done. I've had some of the worst students ever in geometry memorize this. So if they walked away with anything, they walked away with this. So it can be done. Basically just keeping that little setup in mind. So find the distance between each of these two pairs of points. 2, -1, and 5, 3. Well, we're going to designate whichever one. And it doesn't really matter. Okay, I'm going to show you something. I'll come back to this when we're done. So if I decide that 2 is x sub 1 and 5 is x sub 2, you plug them in. 5 minus 2 squared plus 3 minus -1 squared. You end up with 3 squared plus 4. 9 plus 16 square root of 25. Now I'm going to show you something that may or may not find interesting. Doesn't matter if the y's are in front or the x's are in front, first of all, because of this, because of the plus sign. And we're subtracting these, and it doesn't matter. As long as you keep x's together and y's together, it doesn't matter. You can screw this up. So let's say that I'm going to come over here and I'm going to make a mess out of this. I'm going to say 2 minus 5. Actually, you know what? I'm going to make it even worse. I'm going to screw it up even worse. I'm going to put my y's up in front. And I'm going to put y sub 1 first. So -1 minus 3 squared plus, and I'm going to say 5 minus 2 and square it. Well, it really doesn't matter what happens, because when I have -4 here and I square it, and I still end up with 3 over here and square this, I still end up with 9 plus 16, right? Actually 16 plus 9. So that is the same thing. I'm going to end up with the same answer. Square root of 25 is 5. So you really can't screw this up. As long as you keep x's together and y's together in the parentheses, you can't mess it up. Okay, so it doesn't matter. Let's go over here. I'm going to say the square root of -4 minus 2 and square that. And I'm going to say plus -3 minus 0. I've got them totally out of order, but I still have, oops, both y's are together, both x's are together. Oh, and I want to make sure I square this. So, -4 minus 2, -6 squared, plus -3 minus 0 is -3 squared. -6 squared is 36, plus 9 equals the square root of 45. Any perfect squares going to 45? Yep, 9. So that's equal to the square root of 9 times the square root of 5, which is equal to 3 square root of 5, right? Well, here we go. Let's see what they have to say here. They go through this, designate which ones are what. Who cares? Doesn't matter. Just keep x's together, y's together, and subtract them.